Hi, Chris Kuzmal here. Today we're going to describe the delete function for binary search trees. The delete function takes an argument that is a node, which it's going to delete from the tree that the node belongs to. This assumes that the node belongs to only one tree. Um, and I go ahead and have a printout here, which actually I should remove, but this prints out that we're deleting that a particular node. Um, if the node is childless, then we're going to scrub the parent of A, and that's all that we do. In previous videos, we went through the scrub parent method. If A has one child, then we splice A out. In a previous video, we went through the splice out method. And otherwise, that is to say, if A has two children, we rotate A out. And in a previous video, we've covered rotate out. But nevertheless, let's visualize what those options are, okay? So when we delete, we're either going to scrub, splice, or rotate. Suppose that we scrub. To scrub, that would mean that we have no children. And so the node down here, node 10, would get deleted. And that is to say, its parent no longer sees that node. Its parent, the parent is scrubbed. And that's all there is to it. That's how you delete a node that has no children. Just make it so its parent no longer points to it. Very simple, really. To splice a given node, if we're deleting node 9 instead, then we simply have to replace node 9 with node 10 effectively. And of course, all of node 10's children. And this can only happen in the event that the only time that we can splice out a node is if it has exactly one child, because then we can just pull its child up to replace it. The most complex case is to rotate. So let's consider the case where we want to delete in this case, the root node. Any node that has two children has to be rotated out. And what's going to happen is we're going to take the node at 14 and move it up. So going back, so note the node here at 13. That node doesn't get deleted, but it seems like it gets deleted. What's actually happening is the node here at node 11, that's the one that's getting deleted. It's being replaced with 13. So its successor replaces it. And the successor itself is guaranteed to have only one child, not only one child, well, either one child or zero children, but certainly no left children, because as its successor, that's a characteristic of the successor of a node that has two children. And we can talk about why that's true, but that is true because after all, your successor is going to be the furthest left element, the minimum element of your right subtree. And to get the minimum element, you're going to keep going to the left as far as possible. So if you have a left child, you're going to take that left child. If you don't have a left child, well, then we're good. And so that's what happens when we delete a node which has two children. We replace it with its successor and then scrub it. Okay, and that's the difference between here and here. And that's it. That's how you do deletion for binary search trees. Nodes have either 0, 1, or 2 children. We either rotate, splice, or scrub the node.